Hello everyone, hope you all are doing well. So in this video we'll discuss the second problem of Leetcode Weekly Contest 357. A medium level problem, but yeah, it involves a good concept. So we'll discuss that. The problem name is check if it is possible to split the array. Okay. The problem statement says that you are given an array nums of length n and an integer m. Okay. You need to determine if it is possible to split the array into n non-empty arrays by performing a series of steps. Okay, remember the size of the array is n and I have to split it into n non-empty arrays. That means I have to make arrays such that each array has a single element, right? In each step you can select an existing array which may be the result of previous steps with a length of at least 2 and split it into two subarrays if for each resulting subarray at least one of the following holds, right? Okay, the length of the subarray is 1 or the sum of elements of the subarray is greater than equals to m. Okay, so what I can do, I can pick up a subarray. Okay, I can pick up a subarray. Maybe this subarray is because I've split the original array into two halves or whatever is the configuration, but I can pick up a subarray and I can further split it. And when I split it, obviously I get two subarrays from this one, right? So any one of these two conditions should be satisfied for both these subarrays. What are those conditions? The length of the subarray can be 1. Okay, or the second condition is the sum of elements of the subarray is greater than or equals to m, right? Simple. Okay, we'll come to the example and this will become more clear, right? Return true if you can split the given array into n arrays, otherwise return false, right? What is a subarray? Subarray is a contiguous non-empty sequence of elements within the array, right? Like this, these are the elements, right? I have 2 and 1. M is equals to 4. Okay, what I have to do, I have to create how many groups? 3 groups. Okay, 3 groups. So let's start the two. Till now I have 3 elements, so let's pick up a subarray, right? You can do anything, right? You can do anything. In this case, suppose I pick up the array and break it like this. Suppose I break it like this. So what happens if I break it like this? I get one subarray as 2. So one condition is satisfied. So any one of these two condition needs to be satisfied, not both of them, right? Anyone. So yes, the two subarrays that I get, the first subarray satisfies my condition, but the second subarray, the sum of the elements is 3. But I want the sum to be greater than or equals to 4. So that means this split is invalid, right? This split is invalid. Now let's try out different split. 2 2 1. So I split from here. Now instead of this, I'll split from here. If I split from here, again let's see, this is one subarray I get, this is the second subarray. Now this is a single element, so the first condition is satisfied. This is the second, what do you call it, subarray. Now in this, the sum of elements is 4, and what do I want? It should be greater than or equals to 4, right? So that means yes, this is a valid split. So what do I get? After step 1, I get 2 subarrays. This is one subarray and the second subarray is 2, 2. Now I can simply split it from here, because when I split it from here, I get 2 single elements, and a single element is always a valid subarray. Getting it? This is what we do. Simple. This is what the problem is asking us to do. You have to split n elements into n groups, right? N single subarrays. Okay. Let's come to this part. This is 2 1 3. Let's explore all the options. Suppose I split from here. I get 2. Yes, this is valid, but the sum is 4. I want the sum to be 5. Then 2 1 3. Let's split from here. This is a single element. Great, but the sum of these elements is 3. I want 5. So no split is possible. Getting it? Even I'm not able to perform the first split. Forget about the other splits, right? Great. Let's come to this part. This is 2 3 3 2 3. Now this will be interesting. I split from here. This is great. 3 3 3 9, then 11. Okay, the sum is 11. So yes, this is a valid split. Now I have this part. Let's split from here. This is also valid. What about this guy? 3 plus 3 6 7 8. Yes, sum has to be greater than or equals to 6. That's also great. Let's split from here. Now what happens? This is valid, but the sum is 5. So that means this split is not valid. Okay, this split is not valid. Getting it? So I have to take some other configurations. I can take like this: 2 3 3 2 3. So first let's split from here. This is valid. What about these guys? It's 10. Okay, it's 10. Now what we can do? We can simply split it like this. Suppose I split like this. So this is valid 3, 3, 6 and 7, 8. Great. Now split it like this. This is also valid and this is 6. Also valid. Now split it like this. So I was able to split all the elements into single subarrays, right? This is what the problem is asking us to do. Now, seeing the examples, you must have observed that we cannot, or rather, I have to explore all the options, right? I have to explore all the options. I cannot go with a greedy approach, right? Why I cannot go with a greedy approach? I'll come to that as well. Okay. So let's first see, right? Suppose this is your array. Okay. This is your array. Now, initially I have all the elements. So let's assume I have n elements and the total sum is capital S, right? Capital S. Now, just think like this. You have n elements initially together, clubbed together, right? Now, what you can do, you have to split such that you form valid subarrays. Now, what is the condition of valid subarray? Either, so one subarray has a single element, right? Or rather, any one of those has a single element, right? Maybe they do not split such like that. Like for example, if I split it like this, so none of the subarrays is a single element, but sum of this is also greater than equals to 1 m, sum of this is also greater than equals to m, right? So we'll simplify it. What we'll do, we'll take the whole subarray and at every step what we'll do, we'll try to remove one element either from here or from here. Now what's the condition of removal? Just see. So initially I have total n elements. To go with the best case, what I'll do, out of those n elements, right, out, or rather I would say out of all the elements that I have clubbed together, I'll move the minimum element, right? I'll move out the minimum element. Why am I doing it? Just see. Look, total n elements are there. If you remove one element, maybe from here, I don't know from where, right? If you remove one element from here, what happens? You are left with a subarray of n minus 1 elements and a subarray of single element. Now, a single element subarray is always valid, but this n minus 1 will be valid when its sum is greater than equals to m. Now, to maximize the chances of this sum being greater than equals to m, I will try to remove the minimum element, right? Out of those n elements, whatever was the minimum element, either the first one or the last one, I'll try to remove that one, right? So that there are higher chances that my sum is greater than equals to m. For example, if the total sum is 10, this is your array. If the first element is 1, the last element is 5. So obviously you'll subtract this element so that you get a sum of 9, right? You get a sum of 9. If you subtract this, you get a sum of 5 for those remaining n minus 1 elements, right? So this is the approach we'll follow. But I'm telling you why greedy will not work here. If you try to apply it in this example itself, just see what happens. 2, 3, 3, 2, 3. What's the total sum? 13. Okay. So one pointer is here, one pointer is here. Let's try to remove the minimum one. Okay, I remove it. What's the sum of remaining elements? 11. Great. Now again, let's try to remove the minimum element. Now this is also minimum, this is also minimum. Let's remove this. Okay, what do I get? I get 8. Now this is what I am left with, right? Again, let's remove the minimum one. This is 3, right? Because here also I have 3, here also I have 3. I'll just remove one of them, right? Okay. So now what happens? Let's remove it. So if I remove this, it becomes, the sum becomes 5, and this is all obviously a single element, so this is valid. Now just see, I want my sum to be greater than equals to 6. But this is 5, hence this split is not valid. Okay, so every time picking up the minimum element is also not working. Why it is not working here? Because 2, 3, 3, 2, 3. Here I was removing from left, but actually what was happening, there was a smaller element in the middle because of which my sum was decreasing. Okay, so how do I see the configuration of the array? It's tough, right? It's tough to see the configuration of the array because you can have a number of possibilities. Now what's the other approach? A brute force approach would be, let's explore all the possibilities. For example, if this is my array, let's do one thing. Let's remove an element from here. I have remaining n minus 1 elements. Now if the split of these n minus 1 elements, somehow I calculate it, and if this is valid, so this single element is valid, this is also valid, yes, I can split the array. What's the second possibility? These are n elements. Let us split it from the end. If the first n minus n elements somehow form a valid array, like if I can split this into n minus 1 subarrays and this is also valid, then that means yes, I can form a valid subarray. I can form a valid, a combination in this case. So either this holds true or this holds true, right? So exploring all the opportunities, either moving the first element or the last element, right? That's what we have done here. Exactly the same thing we have done here. Let me show you the code. Look, this is the main function. This is the number of elements I have. Now, just see if the number of element is less than 3, then you return true. Why you return true? Let's see that if you have a single element, that is valid. If you have a couple of elements, doesn't matter what the value of those elements are, you can directly split it, because the two subarrays that you get are single elements, and single element subarrays are valid. So that's why I've added this condition. Now, forget about this thing. I'll come back to this. Let's take what's the total sum. This is the total sum of elements. Let's call a function. I pass the numbers that I have. I pass the starting index of the current subarray. So initially I pass the whole subarray, first index, last index. This is the expected sum. This is where I'll store the answer, and this is the sum of the current subarray. Let's come here. Now just see the core logic here. Just see the core logic here. The core logic is, I'll come here and I'll again call the function. First, I'll try to remove the first element. This is my array. This is start index. This is end index. Let's remove it. If I remove it, what happens? I pass num. Now my new subarray for which I need to check can I split or not. It becomes start plus 1 say end. Start plus 1 say end. M remains same. Memo remains same. What's the new sum of the subarray from start plus 1 to end? It's whatever is the current sum minus this element. Simple, right? So if this is true, or again call the same function, can split nums start end minus 1 in this case now. So once we check by removing the first element, now we'll check by removing the last element. So the new subarray will be start to end minus 1, and the sum will be current sum minus nums of get end, right? Simple. If any of them is true, my answer will be true, and I'll store the answer. Why I'm storing the answer? This all thing is because of that only, right? I'm storing the answer because this is a typical dynamic programming problem, right? I'll be calculating the same thing again and again. So why to calculate it? Let's store it. That's what I'm doing. That this guy tells me that, can you split a subarray from this index to this index in a by some valid steps, right? If you can split, don't calculate it again. Just return it. Simple. Just return it, right? That's what we are doing. Now let's do one more thing, right? Let's see one more thing. Look, if you have a single element, this is the base condition. If you have a single element, just return true. Okay. And if the current sum, right, whatever is your current, whatever is your subarray, right, whatever is your subarray, if the sum of that subarray is less than m, return false. These are the base conditions. Single element true, sum of the current subarray is less than m, return false, right? Remember, a single element can have a value less than m, so that is why I've written it first, so that we return true, and else you return false. So just see what I'm doing. Whatever is my answer, I store it here. Okay, if answer is false, store 0, else store 1. Simple. And return the answer. Simple stuff, right? If you are new to dynamic programming, maybe this is not that complex, to be very honest. We are just exploring both the options, but yeah, this is a good starter to understand how dynamic programming works, right? So just see what we are doing, exploring both the options and just storing the answer based on that, storing it so that I do not have to recalculate it, right? So yeah, that's it for this solution. I hope you learned something new from this video. Do support it by giving up a thumbs up. Do subscribe to the channel as well. In case you have any queries, mention that in the comment section. I'll revert on each one of them. Thank you. Take care. Bye bye.